Of all the applications of generative AI, coding and software engineering seems to be one of the more popular ones, where businesses and business leaders in different areas of the enterprise have been a little bit more cautious or challenged in terms of finding ways to adopt and actually use generative AI. Software engineers have been much more willing to kind of jump on board. And what we've seen in the past couple of years is that generative AI tools are being A, optimized for coding, and B, incorporated into the software engineer toolkit. Code generation only represents one component of software engineering. The whole other component is more focused on code review. And so, especially for larger companies, especially for companies in high stakes environment like aviation or healthcare, the review process might be even more important than the generation process. They have to make sure that before they ship new code, before they ship new updates, the new stuff won't break the existing stuff. And so today we are taking a dive into what this world of AI augmented and potentially eventually fully automated code review looks like with Graphite, a company that's been around for a few years, since before the generative AI large language model boom that we're still kind of living through, that launched around a scalable, automated code review platform. And to walk us through it is Graphite's CEO, Merrill Lutsky. This is the Deep View Conversations. Merrill, thanks so much for joining me today.
Thanks for having me, Ian.
Yeah, so as always, there's a lot to get into, and just around this notion of agentic and automated and AI coding. But I want to start specifically by kind of exploring Graphite. And before we get into the technical aspects of what it is and how it works, which I definitely want to get into, I know you have a bit of an interesting kind of foundational story of how the tool came about. And I wonder if you could just kind of walk us through how it got started.
Happy to. I think it's one of the most interesting and has been kind of one of the most fun parts of building the company is sort of seeing how Graphite has evolved over the past few years. So, for those of you who don't know, I'm Merrill, co-founder and CEO of Graphite. We're building a code review platform for the age of AI. So we combine kind of best-in-class workflows and tooling that was inspired by code review systems at places like Meta and Google, and now with an AI code review companion that gives engineers instant feedback on every code change, so cuts down review cycle time and helps some of the world's fastest teams ship faster than ever. To go back to kind of the beginning though, this really it grew out of an internal tool that we built for ourselves in the early days. So when we came together, the three of us on the founding team, it's myself, Tomas, and Greg. All three of us were friends from Harvard and in a lot of like the CS courses and the startup community on campus. We'd all kind of seen what great tooling at bigger companies look like. So Tomas had been at Meta, Greg had been at Airbnb and Google, I'd been at Square and Oscar Health. So had all kind of seen what those like great developer tool chains at places that have a dedicated dev infra team look like, and then also what was available to startups outside of those walls. But so I think we had the right thesis in the beginning, which was internal dev tool chains are just so much better and easier to use than what's available externally. But we'd picked the wrong entry point. So in the beginning, before we pivoted to Graphite, we were building a tool for for releasing native iOS apps that let you basically roll back an iOS app release in the same way you can roll back a bad web deployment, kind of feature flagging successive versions of the iOS app and letting you do that on roll back instantly on the customer's device. What happened though is we kind of stumbled on Graphite in that the first few engineers we hired were all ex-Meta folks. Many of them worked with Tomas before, and basically what happened was we'd bring them in, we'd set them up on code review on GitHub and teach them kind of how we do code review. and they all had this kind of instant reaction to it of this like allergic reaction around the workflow, and felt like they were really slowed down by the pull request process that anyone who's worked at a company that builds on GitHub is familiar with. And the main difference is that in the typical GitHub workflow, like let's say that you're building a feature, you're probably going to go and write write all the different parts of that feature in one pull request. You might have like model changes, API changes, like different changes on different clients, and that's likely all happening in one generally pretty big PR. You write that, you ship that, or you send that off to be reviewed. And then you kind of have to sit on your hands and either find something that's like totally orthogonal in the code base that's not going to cause conflicts, or just do something else while you wait for code review. And this kind of dead time in the review process is something pretty much everyone's familiar with. It gets a lot worse when you have a remote team where you might have to wait for an entire day to get feedback from a colleague halfway around the world. And then, by the time you make your edits, respond to the review comments, it can be several days of back and forth before you can ship. By contrast, the way that the workflow that Meta and Google use is this idea called stack diffs or stack PRs, where instead of writing that large monolithic PR, the tooling helps you break up that change into a series of smaller dependent changes, each of which can be atomically tested and reviewed. And then the tooling will help you if you need to go back. Let's say that you write some code at the base of that stack. You build some things on top of it, and then you have to go back and change something at the bottom in response to a review comment. The tooling will then help you propagate that same change up through everything else you've written on top of it without having to resolve the same rebase conflict 5, 10, 20 times throughout that chain. So the beauty of that is that it parallelizes the review and development processes. So you no longer have to wait for someone to give you a review. You can kind of push your changes as you write them, and keep working on the next most important thing, even if it's dependent on code that you've already written that hasn't yet been reviewed and merged. So by kind of breaking that dependency and making it not no longer this sort of turn-based process and more something that can happen in parallel, you'd end up just being able to ship a lot faster. So basically, to come back to our team, like the first few engineers that we had here were just so frustrated by not being able to stack that they, in one of our hackathons, they built an internal CLI tool that let them kind of replicate that workflow on top of GitHub. And that kind of quickly became something that a lot of our team used. At some point, they ended up sharing it with a few other ex-Meta colleagues, and then something really interesting happened, which was the word really spread about that quickly, and we started getting inbound from other ex-Meta folks at different startups that were like, "Hey, I heard you built the stack diffs tool. Can we use it at our company? Like, do you have this available?" And we'd be like, "No, we're working on this other thing. It's hard coded to our repo. We've never really intended for this to be something we'd make available externally." And there were even a couple times where we would be demoing the iOS rollback tool, and an engineer on the other side would be like, "This is cool, but I really want to hear about the stack diffs thing that you've built. Like, I want that's the thing that I really came here for." And eventually that just became kind of too loud to ignore, and we ended up making the decision. The iOS app was the rollback platform was growing slowly. We had some fairly large like fintech and consumer iOS apps that were using it in production, but it just wasn't the type of excitement and the level of enthusiasm that we needed, and wasn't really. And it was pretty clear to us that like there's just so much more enthusiasm for what we were building in code reviews. So that was kind of what set what set us down that path. And since then we've built out. kind of a whole tool chain that you need to build to support the stack diffs workflow. Everything from like how you create stacks, how you review them, how you merge them all together in atomically without having to like sit there and manually click like merge and then rebase everything like for every single PR in the stack. A lot of different tooling that we've built to help teams work on this at scale. And now we have teams like Shopify that have 5,000 plus engineers that are all running their entire code review process in their monorepo on Graphite's tooling now. So that's kind of it's fun to, but it all kind of emerged from that pretty organically from this like internal tool that we built in the early days.
That decision point that you're talking about, it must be kind of fun to go back and think about it, but I'm sure in the moment, you start a company to sell something else. The something else is good, but it's not taking off the way you want. And then you stumble upon this other thing. I guess that decision process when you sit down and you're like, okay, you know what? We're going to, like, the thing we did by accident, we're going to make that the thing we do.
Yeah.
Is that a scary moment for you and the team?
Yeah.
To be
it was
we started the company to do something else. Like, is that like an existential like flex point looking back on it?
Yeah, it was definitely a scary proposition because we had customers, they'd agreed to pay us, and they were like reasonably sized companies. It's fun now. Many of those first customers that we had on the iOS rollbacks tool are now Graphite customers, which it's fun to kind of see that come full circle. But at the time it was fairly terrifying, especially because we only had about a year of runway left at that point. It was basically like we have one more shot. We're either gonna like double down on iOS rollbacks or pivot entirely into code review. And I think part of how we defanged that was we designed kind of a test for it where we said let's focus on this entirely for a month. If we can get to, I think we said 20 engineers using this every single day at work at companies that we know and respect, that'll be enough signal and then have them all join a Slack channel and agree to do a half-hour Zoom call with us every week. That will be kind of enough signal for us to say, like, okay, we built something really valuable here. Let's focus entirely on that. And we ended that month with 50. 50 soon became 100. Like, I think once we in the beginning of the decision was pretty scary, but then as soon as we started to see the user love for what we were building, I think then the decision became pretty clear by the end of that first month.
Yeah, it's such an interesting part of the story. Like, you do have to kind of take that plunge. And the water's cold, but once you're moving, you're like, oh, gut decision. Yeah, like this feels right. Yeah, no, it's cool. Okay, so let's talk about Graphite now then, like this tool that pushed this whole journey forward. How does it work? Like, what you mentioned a tool chain that you have now. What does it consist of? How are you training and testing and validating it? How is it doing what it's doing?
Yeah, there are a couple. There's a bunch of different components to it, and I'd say like it is this tool chain that like when teams use kind of everything together in it, especially I think get a ton of value in terms of the workflow it enables. So in the beginning, what we were building was really a code review platform. So kind of before, and this was kind of before LLMs got really good at code understanding and generation. The first thing we were building was just this platform where engineers create, review, and merge pull requests. So we have a CLI tool and a VS Code extension that lets you create stack pull requests. Will now auto generate. We can auto generate like the title and description, and really make sure that for reviewers you're clearly communicating what is this change, what is it doing, and walking them through the different all the different files and key points of that. There's our dashboard, which has an inbox that shows you where is every code change in the process right now, like who is waiting on me to unblock them with a review? Where are my changes? Are they, are tests passing on them? Are they, which changes am I waiting for somebody else to approve? Which ones are in the merge queue right now? Just like giving you a single pane of glass into where everything is, which is surprisingly hard in GitHub. A lot of engineers will make we'll just have a collection of bookmarks of like custom filters in the GitHub PR search, but having everything in just like one clear inbox ends up being really helpful. There's the actual pull request page itself, which shows you all of the context on the code changes, what needs to happen in order to unblock this, the stack as well, so showing you the other PRs that are linked together with it. And then there's the merge queue, which coordinates merging for a given repo in a given trunk branch, coordinates like merging all the PRs that are being merged at a given time, and enforcing an order and making sure that you don't have a case where where someone merges a change under you that ends up breaking the functionality that you built. This just gets exponentially worse as you increase your team size, and becomes pretty critical once you have more than 100 engineers or so working on one trunk branch. So that was kind of the core. That's like the core Graphite platform, kind of built to accelerate code review pre everything that's happened with LLMs. Now, obviously, what happened over the past year and a half really is that with the advent of all of these AI code generation tools, every single engineer has these amazing levers that help them build features faster than ever, go from 0 to 1 on something in an incredibly short amount of time, and as a result, they're writing code faster than ever. They're creating more pull requests than ever, and teams of 10 now have the scaling challenges the teams of 100 used to have, and we were sort of really well positioned in that we've been building tools to kind of accelerate that outer loop of how, once you've written code, how do you make sure that it's reviewed and tested and deployed safely. This has always kind of been the big bottleneck at larger companies. Many of them have internal dev infra tools, dev infra teams that focus on building tooling to accelerate those processes. That was basically the problem we were solving before AI code gen. So we're now really well positioned to both help teams deal with the increased volume of code that they're dealing with, and also then to apply AI to help review as well. So around this was last September, we launched what we now call Diamond, which is our AI code review companion. Which is basically an agentic code review companion that'll scan every change in a few seconds once an engineer puts it up, and then give them feedback much like a human reviewer would. So it can find it finds things like bugs, nits. You can give it a style guide, and it can enforce those rules in the style guide. It'll find security vulnerabilities. It'll find logic errors. Basically all the different types of comments that you can expect. Short of, I'd say we're still not quite at the point where it can do like super high level architectural thinking, but I think we'll get there in due time. But all of those first pass code review comments that you normally get on a PR, Diamond can now generate those in a few seconds. So what used to take a couple hours or maybe even a day or half a day to get feedback, now engineers that are using Graphite just get that in a few seconds, and they can make those changes. Diamond will actually suggest, in many cases, it'll suggest the code change to fix the issue, and then the engineer who's authoring the PR can accept it with one click, and all of this happens kind of before a human reviewer needs to then look at that pull request. So the net result is you end up saving hours and hours on every single PR. We've had some case studies where Asana was saving 7 hours a week. Ramp is shipping 3 times faster now as a result of Graphite. Really cuts down on the cycle time, and we think about it as a complement to if you have a tool like Cursor or Windsurf that you're using to generate code. it makes so much sense that you then also have like an AI tool on the other side that's helping you to review and test and deploy that code as well. And almost without it, I think you're kind of missing a lot of the productivity gains of AI code generation. If you're generating this like mountain of pull requests that's just getting like gummed up in the rest of the process.
Mm-hmm. I'd love to kind of pop the hood on Diamond a little bit.
Yeah.
And so, I'll just kind of throw a bunch of things at you. Is this a model that you guys kind of built in-house? It sounds like a large language model, but is it a system that incorporates a bunch of different types of models, maybe classical machine learning in addition to other stuff? How is it trained? How do you validate that it's going to do, these things properly?
Yeah, so it's based primarily. We work really closely with Anthropic. So under the hood, it's based very closely on Anthropic's Claude 3.7 model now. We do a lot on top of that though, in terms of like our prompting and scaffolding to make sure that we're generating. I'm trying to remember the number of calls that we use, but we're making a lot of calls on top of for every single comment that we're generating in order to make sure that those are high quality and that we're able to like get the full context there. So we start with kind of high level scaffolding, like asking it like how can we improve this PR. We'll traverse the code base. We'll generate a list of improvements and bugs to call out. We'll have we do some voting to narrow down like is this change different from the existing code? Like, does this refer to something that was introduced in this PR or not? Sometimes it'll find comments, but it'll actually find relevant feedback, but it'll be from like a previous change, and we probably shouldn't comment that. So a lot of work to then narrow down on like, is this a comment that we should actually be surfacing to the user or not, and then present those. And one of the key things underneath this is just our panel of evals that we've built over time. So we have obviously a lot of feedback from our users that we use to help inform this. We've also generated, generally, since we don't train on like that code specifically, but we'll generate if we see like types of comments that are frequently being flagged, we'll generate a bunch of examples of those to feed into of similar scenarios to feed into our evals, and then make sure that we're improving Diamond for everybody else on top of that. So a lot that then goes into like making sure that the comments are high signal. That's one of the biggest learnings we've had is that it's very easy. The first, I guess, if we go back to what we did in the early days of this, like our first example of this was the super naive, like give feed in the PR and say give this a code review. And what you'll find if you do that with any base model is that you just get a ton of spammy comments. You get a ton of things that are going to piss engineers off. Like they'll say like, oh, you should add a comment describing what this function does, or something like that, or it'll say like it'll speak from one thing that we found that's kind of funny is without any guardrails, a lot of these models will say like, we should change this thing, and it's like, well, it's not we, like you're not a part of, Claude is not a part of the team. So lots of little things like that we then have to like narrow down over time and identify and kind of tune this to be much more of like the types of comments you'd expect, and that are high signal. I think if you can get a lot of AI tools end up just generating a ton of comments or a ton of slop, and especially for engineers, like they're so discerning, like it's so easy to just filter out like this isn't a useful tool, like, this tool in general isn't useful, I'm just going to ignore alongside the 100 other bot comments I have on this PR, is this really something that I should be paying attention to? So I think that's really what set Diamond apart, is that we've really optimized for that like high signal to noise ratio, and making this feel like a trusted senior member of your team.
It's an interesting point about the importance of I like to think of it of kind of like sprinkling a little bit of determinism into something that's non-deterministic, in order for it to actually work in a way that makes sense. And I guess what you're finding is that like letting these kind of models just kind of run free reign doesn't really benefit high performing software engineers. But if you scaffold guardrails and rules around it, then you have something that's powerful.
Exactly. Yeah, I think that you really need to like take the raw feedback and introduce like either through in some cases deterministic rules, in some cases like more calls, like asking it more questions about the responses that it's generated. Like then you can start to design and get down to something that's higher signal and that's going to be better received by engineers on the other side.
Mm-hmm. And so I think you kind of alluded to some of this earlier, but that this is enabling, or Diamond and Graphite are enabling people to just ship faster,
Yeah.
do more, ship more quickly. I wonder about the time savings and what that looks like on the ground. And I guess part of that is related to trust. Like, do you find something where they're able to produce more code, but engineers are still spending as much time or more time reviewing that was reviewed to make sure that it was legitimate, because these models do screw up from time to time? Like, is there a thing where in speeding it up, it's slowing it down because they can't trust it? Is that something that you're finding?
That's a good question. I think that one of the core principles that we've had with Diamond from the beginning is that we don't see it as a replacement for a human reviewer, like much in the same way that I think like a cursor or windsurf isn't a replacement for a human engineer. I think we want it to just augment reviewers, and by that I think we can have it find a lot of the like more tedious like the more tedious parts of code review. It can automate for you, so it'll find a lot of bugs. Like sometimes it does actually. Like there are some of the comments that it makes that end up not being relevant, and that ends up much like with a human reviewer or something. You don't accept every comment that a human reviewer makes. But I think the goal of it is to catch catch a lot of those like first pass at code review type of comments that that. Otherwise, if you're an engineer who's reviewing a PR and you find a few bugs in it, you probably say like, okay, like go and fix these, and then we'll talk about this again. We can kind of shortcut that first pass at review and say, all of the Diamond will identify all of those issues. The author can then fix them before that your human colleague ends up reviewing it, and that way you've kind of saved that. You've saved that extra back and forth, and you've probably made the review experience a lot more enjoyable for, or at least like less painful for someone who can look at this and say like, I have higher confidence this is going to be bug free. I can focus a little bit more on the higher level like architecture and product thinking that went into this. And I think that's much like with code generation. What we're seeing is that, at least anecdotally, is that it does make, it takes away a lot of the tedious parts of review, and it makes the experience of code review a little more focused and enjoyable.
And the code review versus code generation part, I mean, versus is not the way to do it. They kind of work in tandem.
Yeah.
But for you guys specifically, obviously you get into code review kind of backwards, you stumble into it, and now you have a thing that seems to have become potentially much more valuable than even you realized it was, as we enter an age where there's AI generated coding in the first place. And in that, where now you happen to have this tool chain to work on code review, I with the companies you work with, why is code review so important? Because I feel like some reports have come out that at some of these big companies especially, their engineers spend way more of their time reviewing code because you're talking about these massive infrastructures than they do actually generating code. And the more important thing to work on is the review. The generation is like little bits here and there.
Yeah, I think that's exactly right. That it is like code review is so important because it takes up so much of engineers' time, especially at the largest organizations. Like it ends up being, it can be hours every day, like days every week that go to the the coordination around and this outer loop process instead of being able to focus on writing code. And I think that only gets worse, as you have more and more AI generated PRs. That's only going to get worse. There's only going to be more demands on human time to review without having some kind of assistant similar to what we've built. So I think that you're starting to see this at a lot of. I think there was a case study. So interestingly, Ramp uses both. I think there's a case study that they published with Cognition the other day where they they basically said like the bottleneck for development is no longer and hasn't been how fast we can build a feature, like create the code for it. It's how quickly we can review and test and deploy it. And that piece, I think, just becomes, especially as you have these agents that are now being able to kind of autonomously go off and write PRs on their own. Having tools to help you like review that code faster is just critical to unblocking the development process and shipping faster. And I think that's a lot of what there's this initial exuberance around the productivity impact of code generation. I think now talking to a lot of CTOs and CIOs, they're seeing that there's that then you then have to, that's only part of the picture. You then have to complete the rest of the story with outer loop tools that can keep up with the rate at which these agents can generate code and the rate at which their engineers can write code now. And that's a lot of what makes us, what's so exciting about building in this space is that there's just so much opportunity to unlock more efficiency, help teams ship faster than ever, and adapt to this new way that software engineering is being done.
Mm-hmm. I'm wondering, now that you kind of are incorporating Diamond as like your AI answer to the AI stuff, but before and on top of that, you have the Graphite platform. And so, I wonder how the cost on your end scales, because before you have Diamond, you're not dealing with large language models, and so. We know large language models, the cost of inference is expensive, especially I think 3.7 is the hybrid reasoner, if I'm remembering. And so you kind of activate these different things. And especially as you get into the reasoning stuff, the cost of inference just kind of keeps going.
Yep.
And for you guys, where, before you deal with stuff like that, it's you're not dealing with that kind of cost. What's the scalability of offering that as a tool?
Yeah, no, it's a great question, and it's something that we've thought a lot about. We just made an update. One of the updates that we launched last month with Diamond was making Diamond more agentic, so it can go and browse. It'll go and browse the code base. It'll gather the context that it needs before making comments, and that's obviously it's massively increased the quality of comments that we leave, but it's also increased our costs a ton because we're just doing so much more reasoning to go into every single comment. And I think that's why we wanted to make sure that we were that we charge something for it and that we're covering our costs, and that we're able to offer this sustainably. But our view right now is pretty aggressive. That I think much like many others in the space, we expect that inference costs will continue to drop off over time. We see that trend's has been happening for the past year really. So our bet is really we're investing a lot in this. We're not looking at this from a margin optimization standpoint. Our goal is just to deliver the best possible product experience, and and also I think connect it to the nice part about it is because we have the rest of the platform, we're not just an AI code review plugin to GitHub. We have this whole developer experience around creating, reviewing, and merging PRs that almost you can use Diamond separately if you just want to review in GitHub and continue to do the rest of your developer process as you have, but it really works the best when you combine it with the rest of the Graphite platform. And I think that's kind of the beauty of it for us, is it's come for the the AI code review stay for the workflow tooling, and that piece. And they, because they integrate so well together, like if you use the two together, we can do things like suggest fixes to CI failures when they happen. We're working on a lot of more ideas of like places where we can have Diamond basically like keep your pull request in motion versus having to have it stop at every single part of the process. And I think that that by having more to it than just more to than just the AI review model, I think that really that from a business standpoint makes it a lot easier for us to justify like let's invest a lot, let's take a bet on inference costs going down in the long run, but not think about this as like a high margin bet at the moment.
And the other thing I gotta ask you about, you're dealing with processing companies' code. I imagine that's sensitive information. Depending on the company you're working with, they may be more cautious about stuff like that. I wonder how you approach data privacy and data security.
Yeah.
And I wonder what you find when you're working with customers. Are people nervous about the idea of an AI review platform coming in and looking at their stuff? Or are they like, bring it on? I've got nothing to hide. Like, where are people at?
Yeah, no, it's a great question. It really varies by. I think it varies by company. Like, there's some companies where the culture is like, our code base is like the most important thing, the most important like piece of IP that we have, and they really go to lengths. In some cases, it's like there's like national security or other it's healthcare data, something like that, where there's like more there's a lot more of a high cost to something like that potentially leaking, where they're very much still like we want to self-host everything, we need to like run the models ourselves. And I think what we've seen for the most part though is that many companies are shifting more towards like running everything on cloud, like being comfortable with other cloud services. And if you see, even thinking about tools like Cursor and Windsurf, it's like all the companies that are adopting those tools, like their code bases are being they're being scanned and being reasoned on remotely. I think that in some cases a lot of companies have decided that the benefits of that outweigh the potential security costs of doing so. Obviously, we spend a lot of time making sure that our any like ephemeral environments that we're spinning up are highly secure. We're regularly pen tested, like SOC 2 certified, everything that you'd expect from a company that's like handling source code. But I think that we've consciously chosen like we don't offer a self-hosted version of Graphite. We haven't yet supported. We're considering supporting like bring your own model or like run it in your own like AWS Bedrock instance. But up to this point, we've kept everything on our side. We have agreements with like Anthropic and OpenAI around like not training on the data that we share. But I think we've taken the standpoint that's I think is in line with most of the AI code generation tools out there in terms of how they approach code security.
The way you've talked about the inner loop, the outer loop, these different tools that are entering into these software engineers' arsenal is about augmentation, not replacement. And I guess I wonder on the road that we're on, is there a horizon where augmentation becomes replacement, where augmentation just kind of morphs into full-on automation?
Absolutely. I think that's the today the product that we're building today is very much one for a world where we are still living in a world of augmentation. I think what we'll see, you're seeing a lot of luminaries out there pointing to like coding not being as important of a skill to have, or engineering as we know it going away in the next year or two. I think the time horizon may be slightly longer than that, but I think that the asymptotically, I think we do approach a world where code is just being generated almost entirely by like progressively more advanced agents. And the interesting thing for us though is that I think in that world as long as humans are still accountable for the product that you're producing and the experience to your customers, there still needs to be some level of human review, and that may not look like the GitHub PR page today, but I do think that there is, as long as that accountability exists, and as long as Fortune 500s aren't trusting agents with the experience of their end customers, which I think will be a long time before that happens. And interesting to think about, like, a fully autonomous company, but I think that it'll be a long time before that happens in practice. And insofar as that's the case, like, review, I think the inner loop may collapse and into the outer loop in some ways. And I think what's really interesting for us is that then the job of an engineer day to day, I think, becomes less like writing code in an IDE and much more like doing code review and kicking off these tasks, like figuring out like what is, maybe even you have agents that are suggesting based on like user feedback and logs of like what are the tasks that we should do. Engineers that are orchestrating, then having like kicking off agents to go and write code to achieve those tasks, and then getting back a pull request, an environment that you can play around with it in, and a code review experience that lets you then like iterate with that agent or with other agents or with coworkers. And I think that's what a lot of what engineering is going to look like in a year or two is much more one where where you're as an engineer, you're doing much more reviewing and iteration rather than like 0 to 1 like writing code and like building features from the ground up. And obviously that's very exciting for us. I think we're in a position where if we can really nail that experience, like we see Graphite as being, currently we say Graphite is kind of second to the IDE in terms of like developer hours spent per day, but I think as the IDE becomes less and less important over time, like Graphite becomes more important, and we can quickly become kind of the place where most of software engineering is happening if we're able to like keep really building an amazing experience and keep kind of facilitating that like human agent collaboration.
So that environment, if it comes of a more complete automation, that's not a scary proposition for you as Graphite. That's something that you're building for.
Yeah, that's a thrilling proposition for us, because I think it puts what we're doing like front and center in that world. The only question then is I think it's more of an execution question for us of like how do we make sure that we build an amazing product experience that's and how do we kind of reimagine code review for an age where you're giving the feedback to an agent rather than a human, and the feedback loops are much tighter. You're not waiting 6 hours or waiting for the next day for the author of that pull request to make the updates. It's happening in a matter of seconds.
Well, so that's Graphite. I wonder, I mean, you come from a background in software engineering. Is the idea of a world where software engineers don't really have to software engineer, where they don't have to like write code anymore? They can just, mainly the agents just handle all of it, and then you can kind of like check in on their progress. Do you think other engineers would miss writing code?
It's a good question. I mean, so for me personally, I'd say I'm, of the three of us on the founding team, I'm like the least like deep into engineering historically. Like I've jumped back and forth between engineering and product. I've certainly written a ton of code in my day, but I think I've always viewed it more as kind of a means to an end. And the enjoyable part of it for me really is like the end result that you can generate with it, and be what do you get at the end, once you've done all of that work, like what is the product experience that you can create for the end user. So I think like for me it's pretty exciting, and that a lot of the things that were the more tedious aspects of building something now can be really handed off, and it just gives you this incredible leverage as a product thinker to be able to like take your ideas and realize them in code as quickly as possible. So I think that for me that's really exciting. I do think that there is some like aspect of like the craft of software engineering that some kind of lament losing in automation. And I think this is much like any domain where there's been like a lot of automation introduced in the past, or like any craft, like I do think that you likely lose some element of like the human enjoyment of it in automating it away. But I think that then in many cases leads to being able to like refine your skills at a different level of abstraction, kind of find that same pleasure of being like really thoughtful and good at something on one level. I think like now we can take that and apply that to the next level of abstraction, and think about that from like product design, brand, like all the things that are now all the more important as the time and the effort required to like go from idea to code approaches zero. And so that I think is pretty, it's exciting to me. I also think that a lot of the more tedious parts of creating high quality software now, like when we think about the outer loop, like there used to kind of be this direct trade-off between like how much time am I going to put into testing this or like writing test cases, and and how versus like how much quality do I like, how high quality do I want this to be. And now if you have we're approaching this world where that trade-off kind of breaks. Like you can have something that's like really thoroughly tested and thought out, and you don't have an agent that's like tired of writing 100 tests for something. Like you can take away a lot of the things that were the most like frustrating and tedious about engineering, and just focus on the things that are the aspects of it that are most enjoyable. So that's kind of how I think about that more like existential question around automation.
Do you think kids should still be learning how to code?
I think so. I think that the reasoning, much the same way that like, I think, do you really need to know to like understand like mathematics, calculus, like are these things that you use on a day-to-day basis? Like probably not, but I think that there's a way of thinking that it teaches you, and what it teaches you about reasoning is still like incredibly valuable to have. And even if you don't, I think much like with today, if you don't need to understand like how like the silicon in your computer works, or be able to like recreate that yourself. But I think that like having a high level understanding of that is still really important as you're thinking about the consequences like at a higher level of abstraction. So for me, I think that these claims of like you shouldn't learn to code anymore. I think that's a little over dramatic, and I think misses a lot of the value, the real value that you get out of learning like any discipline, like coding in particular.
What's the challenge then? I mean, I like that you brought up calculus, because it's a really good point. We're taught calculus. I remember calculus tests. They sucked, but you had to do it all by hand, right? You're writing these things out. For some of them, you were given access to a calculator to do specific calculations, but it's not like, you could Google these problems and you have solutions to it. Other people have solved calculus. I think it's a good point about what we're taught. It's interesting to, I guess, extrapolate that to places where, for the average person, right? Like I learned calculus, but I didn't become a physicist. So I forgot most of it. But today, if you are a physicist, you have the most advanced tools that you could possibly imagine at your disposal, and you also have to have more than just an understanding of physics. You have to also be able to do these calculations if you want to kind of push the frontier. Yeah. And so, I guess I think a lot about education and automation and education and what the kids look like 10, 20 years, where if the tool that just becomes super available of just instant automated coding is so powerful that it really de-incentivizes people to want to learn how to code because they get so obsessed with the quickness they can achieve the end result. You know, for a lot of people that maybe doesn't matter. For the chunk of people, which I guess like for each domain is maybe like 0.1% of the population that is pushing the frontier, that's pushing the edge. I don't know. It's maybe this kind of philosophical question. We're dealing with these hypotheticals and theories and stuff, but could that make it more difficult over time to push the frontier because we just get used to letting AI manage the status quo?
That's a good question. I think that there is it is an interesting philosophical one of like the more like the further along human knowledge gets, the more prerequisites that you have to have in order to understand it. Like even for for these transformer models now, it's just like the amount of like linear algebra that you have to know, that you have to like understand and deeply in order to think about them conceptually is just so high now. And that I think that is that's like a really big challenge over time to just the amount of time that it takes for somebody to like build that base of knowledge in order to work at the frontier. But at the same time, I think one of the nice things is that these tools can help us learn faster as well. So we're able to then, I think one of the things that's been even for me, I think just being able to like ask ChatGPT questions about like topics that I'm not familiar with, and like get have kind of like access to information in a way that at a speed that is unprecedented. I think kind of helps you for those who really want to get to that level. I think kind of helps them get there faster than they've ever been able to before. But I do think that there is like a challenge there of like over time. Certainly it just gets harder and harder to work at the frontier of something. But I do think that there is always like a value in understanding what's underneath, even if you're not working on the very bleeding edge of it. Like I do think that there's like an amount of reasoning, and it helps inform how you think about using the tool if you understand how it works a little bit better. Like even one of the examples I think about a lot is like I remember when I was younger, I never really, it didn't really make sense to me why the advice of the common advice around like turn, if like a piece of electronics isn't working, turn it off and on again. Well, like before I understood how memory worked, like that didn't make any sense. But now I'm like, oh, okay, this now I get why that's like that is good advice if you want to fix if you want to fix a lot of issues. And I think things like that, you kind of miss out on that understanding and ability to troubleshoot or like go off of the golden path if you don't have at least like a high level understanding of what's happening under the hood.
It's a great point to end on there of the more you understand something separate from an automation tool, the better you're going to be able to use that tool.
Yeah, absolutely.
Cool stuff. Well, Merrill, I really appreciate your time. This was a lot of fun. Thank you.
Yeah. I mean, thanks for having me. Really enjoyed chatting about all of this, and excited to see what everyone thinks.
Yeah, likewise.